So I'll say that again. So have you done chapter 8 in mechanics?
Yeah.
Yeah.
We've done all of it.
Okay, yeah, okay, that's fine. It's probably been a long time since you've forgotten. So, yeah, so essentially, if you have R, you differentiate it.
Yeah, we've done chapter 8.
You differentiate it to get V. So V, well the RDT is firstly, well, let's just differentiate that, right? In respect to I, that's going to give us 9t squared because we multiplied the power, then reduced the power by 1. That's going to be minus 1. I'm going to keep it like this, I, plus, and we just differentiate the next one. So that's going to be 4t plus 2j. And obviously it's in meters per second. So that's that. So that's a very easy 2 marks as long as you remember, and I'm sure you're very good at differentiation. Now, if you differentiate it again, then you'll get acceleration. So we're just going to substitute 2 in here, so that's going to be 2 squared plus 5 times 2 minus 2, and that's the I, plus t cubed, you do that for your method mark, plus, that's in a bracket, 2 times 2 squared, and then you're going to get a displacement of R equals 12I plus 16J. Any questions about that?
No.
No? So yeah, so part B, we're just doing dr dt to get V. So when we differentiate displacement, we get velocity. So that's going to be 2t plus 5 I plus 3t squared plus 4t j, right, and it says when t equals 3, so we sub t equals 3 in, and we'll just write that in for our method marks. 2 times 3 plus 5 I plus 3 times 3 squared plus 4 times 3 j, and we're going to work that out as 11I plus 39j, and then put the units in. There we go. Any questions?
No.
No.
I got the.
You got it right as well. That's good. So this is just knowing that skill will get you 1 or 2 marks, even on the harder questions, because it always normally starts off like that. If that makes sense. Can you remember? I think the last one of the questions in your mock exam had something like that, where you had to do that.
Yeah.
Yeah. So you know, already getting 1 or 2 marks is an improvement. And this is the aim, right? We'll try and get a few marks on each question, because some questions are really challenging, and once we do that, you know, you're going to bump up your grade, because it's not actually that many extra marks to move an E to a D or even to a C, and that's our first stage. Right, hello Nia as well. Right, question 3. Now it says find the time at which the particle is travelling on a bearing of 0.45. So if you think of it as a bearing of 0.45, right, that must mean it's travelling in the I, exactly in that ratio, I and J direction, because that will give the 45-degree angle. So that's what we need to do first. So remember that direction, we've got to kind of like find, what do we think we need to find? Or you? Or Nia?
Is it the hypotenuse?
Yeah, we all have to, well, we will have to kind of find the velocity first, because this is just the displacement, right? So we're going to differentiate A. We're going to do dr dt to get the velocity, which is going to give us 6ti plus 4t plus 12 j, right? And that's going to equal our v, our velocity. So for it to be 45 degrees, the I and j component have to be the same. So what that essentially means is we're going to have this has to equal some kind of multiplier of I plus j exactly. Right, so do you know what you have to do from here? Nia, any ideas? Not really. Right, do you understand the concept that because it's travelling at a bearing of 0.45, the I and j components has to be the exact same number? Because that needs to make sense first. Yeah, because that's I and j to make 45 degrees, right? Right, so how can I do this? So that's what I'm saying. K, there's going to be like a ki. Write this down. There's going to be a ki, some number for k, and a kj has to equal all of this together. 6ti plus 4t plus 12j. So what we can say is, what can you see? K has to equal this. So we're going to get k equals 6t. And also k here has got to equal 4t plus 12. So they've got to equal, we can create a simultaneous equation, right? So that's going to be 6t equals 4t plus 12. So you're going to get 2t equals 12. So t must equal 6 seconds. And that will be the answer, because at exactly 6 seconds, these two things are going to be exactly the same number, and that's when the particle is going to be travelling at this bearing. So B, it says find the magnitude of the acceleration of the particle. So this is when, Ollie, we've got to find the hypotenuse, but step 1 for B
Is it to differentiate?
What's that?
Is it to differentiate the velocity?
Yeah, so we have to differentiate the velocity to get acceleration first, right?
Yeah.
Yeah, so we differentiate velocity. So we could call it dv over dt, I guess. dv dt, because that is actually v here. So we get 6i plus 4j. Now, because it says magnitude, that's when we have to do Pythagoras here to get the magnitude. And so that's when we do Pythagoras. So it's just the square root of 6 squared plus 4 squared, which is 36 and 16 root 52. So that is 2 root 13. Meters per second squared. We happy with that?
Yeah.
Perfect. Right. Let's move on to question 4. And I'm going to give you some time to give that a go on your own and see what you can do. Whilst you do that, I'm going to try and find the question in your mock so that we can go over it as well. I'm going to resume the recording. Let's go to pen. Let's do blue. So, part A. So you're essentially integrating this. That's our methodology. J. Now that is in respect to t, so it is the velocity with respect to dt. Okay, so we integrate. So integrating, you increase the power by 1, then divide by the new power. So a is going to equal, v is, this is a. So v is going to equal, if you're going to show you're working out, now remember what happens when we integrate. What do we have to include?
Plus C.
There you go, well done. That's going to be 4t squared over 2. And you're going to have another constant on this side because it's with respect to j. So that could be a plus d, just because we go alphabetically order. Right, now if I just simplify that, that's just v equals t cubed minus 4t plus c. That's I, plus that will say the same, 2 over 3 t cubed plus 2t squared plus d j. Now, because they've given us when t equals 3 the velocity is this, we can use that, right? T equals 3, v equals 10i plus 20j. So we just substitute here, right? So what this means is that 10i component is going to match up with this when t equals 3. Okay, so we can just say 3 cubed minus 4 times 3 plus c equals 10. 3 cubed is 27, so we get 27 minus 12 plus c equals 10, and that is going to be 15 plus c equals 10, so c equals minus 5. Do the same on the other side. 2 over 3 times 3 cubed, and that's, we're doing the j bit now, so this j bit's got to equal the 20j, plus 2 times 3 squared plus d equals 20, and essentially we're going to work that out to be 36 plus d equals 20. So d equals minus 16. Right, and then we can write out the velocity, and I'm just going to write up here. Find expression of the velocity in terms of t. So v equals t cubed minus 4t, c is minus 5, minus 5i, plus what we did for the other one, so 2 over 3 t cubed plus 2t squared minus 16j, and you've done it, and that's the 4 marks that you can all get. Are we happy with that?
Yeah.
Yeah, did we get that, or did you forget to do the C and D?
C, but I did like both of them as C, and it did be separate.
Oh yeah, but can you see you're going to get different answers, so you have to have different letters.
Yeah.
Yeah, okay. So part B is exactly the same thing, right? We integrate velocity to get the displacement. So what I'm going to do is just pause the screen a sec and add another slide. So I've got somewhere to... So for part B, like I said, we need to integrate this. Oh, that's the bracket here. And that is respect to dt. So remember, integration, we add the power. Now integrating velocity gives us the displacement. So r is going to be increase the power, divide by the new power. Increase the power, so that's 4t squared divided by the new power. There's no power there, so it's just going to be minus 5t. Remember the plus c, it is easy to forget. I then plus 1 over 6 that's 2 over 12 first, 2 over 12t to the 4. We're increasing the power, then dividing by 4, so that will make it 2 over 12 plus 2t cubed over 3 and minus 16t plus d, and that's in terms of j. And if you just simplify that, and the key point here, well, that means t equals 0. The particle is in the position r equals 2i minus 5j. So we know 2i is going to equal this bit at t equals 0, and then minus 5j has got to equal this bit when t equals 0. And did we work that out, people, to get C and D?
Yeah.
What did you get for C?
I got 2 equals D.
Well done.
D.
And D equals what?
Minus 5.
Perfect. And once you've got that, you just write the formula. and pull it in. So r equals t over 4 cubed over 4 minus 2t squared minus 5t plus 2, and that's in terms of I, plus 1 over 6t to the power of 4, 3t cubed minus 16t minus 5, and j, and the key point is a distance, and this is in meters, not meters per second. And then, well, yeah, got 4 out of 4 then. So from the start, from question 1 where you didn't have an idea, now you're actually doing a harder type question and you've got 4 out of 4 there. You just needed to be shown that. So that is really good. Nia, did we get there? And William?
Yeah.
Well, okay, nice work. Right, I'm going to show you question 5 and see if I've got time. Brilliant. So actually you should be pleased with that. So question 5, so it's not as hard as you think. I think you can do that on your own. I'll give you some time to do that, because I forget to do that sometimes. So we've got acceleration 3t minus 3i plus 2t minus 4. T is time in seconds. It has this initial velocity, so that's a big clue straight away. Where's my pen? That means t equals 0 here. Now it wants us velocity in terms of the velocity of p in terms of t, so we just integrate that. So we just integrate the acceleration. So I'm just going to write that as, so v is going to equal 3 over 2t squared minus 3t plus c, put the I in, need to remember that, plus t squared minus 4t plus dj, and that is going to get you 1 method mark. Now when t equals 0, v equals minus 4i plus 4j. So this minus 4i has to equal this. So essentially minus 4i, well not minus 4, well minus 4 is going to equal, when t equals 0, c. And 4j, so 4 for here it's got to equal this j component, and you got d as 4 as well, correct?
Yeah.
Perfect. And then all you need to do is write v equals 3 over t squared minus 3t minus c, put that in the bracket I, plus t squared minus 4t plus 4 and a j, and it is velocity, so it's meters per second, and hopefully that's your 3 out of 3 marks, and I know that you would have got that, so that is really good. So you've already boosted up your marks by 3 marks, all you and Nia and William, very quickly. So it says find the velocities at the 2 times p is moving to the vector 2i plus j. So it's going like this, 2i plus j. So it's parallel, so it's going to have some kind of coefficient there. Now this might be the part you struggled with, or did we get there?
No.
Okay. Okay, so this is exactly like the last question in terms of when it said the bearing of 45. So all we do here is write what we have, and this is a skill, but once you learn this, then you've got, and it comes up in your mechanics, you've gone to double, at least double the marks you got before. Right, so we're going to write this down, which is the velocity from before, plus 4j. So do you remember, there's got to be, when vectors are parallel, then you're going to have this component that's going to be the same, as in, for example, 2 to the 2i plus j, that's parallel, right? Because it is times 2, because it's just doing this. That makes sense? Because it's still parallel. So you're going to have a coefficient that's going to be the same. So that's why we can say that's k 2i plus j. But the other question was some constant k I plus j. So all we do here is we know that, so for the I, 2 lots of k, so 2k has to equal this, 3 over 2 t squared minus 3t minus 4, and then that's this kj, so k is going to equal this j component here, t squared minus 4t plus 4. Right, now we want the k's to be the same, so we can double this, times this all by 2, because then we can set them equal to each other to find k. So we've got 2t squared minus 8t plus 8 equals 2k. Now we have 2k and 2k. You can see it says 2 times, so you know it's going to be a quadratic because there's going to be 2 solutions, right? So we're going to set this equal to this and solve. Right, I'm going to set that to 0. So you rearrange that, and you should be very good at this. 0 equals a half t squared minus 5t plus 12. Now we don't like this half, so we're just going to double everything to get t squared minus 10t plus 24 equals 0. And when we factorise, 0 equals t minus 4 and t minus 6. So t equals 4 and t equals 6. We should be happy with this one. That bit, yes?
Yeah.
Yeah, wonderful. Okay, so we're happy with that. Now, look at the question. What's it moving? What's it missing? Are we done there? Because we're going to lose one valuable mark. Are we finished, or have we forgotten to read the question properly? Yes, find the velocities, just so you write that, Nia. So you just sub in t equals 6 and t equals 4 into your velocity formula. So you'll get at t equals 4, v equals 8i plus 4j meters per second, and at t equals 6, v is going to equal, and you're just going to substitute in here and work it out. (32i plus 16j), and there you go. And I think it was question 2 or 3 which was similar to that one, right? So you do need to remember that skill. Does that make sense now, Ollie and Nia?
Yeah.
Yeah, so that's brilliant. So you're actually learning so much in a short period of time. So I think you should be really pleased. So now what I've done is Ollie, do you remember what you got in your mechanics? How many marks in total?
I have 9.
9. Do you know what sections you got marks on?
I got marks in the first question,
Right.
and I think I got marks on like the kind of stuff we did last week.
Yeah, that was question 1.
Oh, okay. I'm trying to think of the other. I can't really remember. I kind of got like maybe 1 mark in 3 of the questions.
Yeah, and you would. Yeah, that will almost make 9 marks. So that makes sense. So we're gonna. So right now I'm gonna show you the last question. So this was question 5 in your mock paper. The last question. So in theory, it's the most difficult one, right? But in a very short space of time, you should be able to get some marks now, where you can see all the questions I gave you before is to build up the skill to answer this one. So this will be our last. Yeah. So really, for this, you just need to write A equals dv dt, right? Which equals times by the power 3 over 2t and minus the power by 1 minus a half, and that's I minus 2j, and we should be professional. That's meters per second minus 2 because it's acceleration. Now you've just got 2 marks right there. Now B, find the values of t at that instance when p is moving in the direction of I minus j. So like what we did before, I'm just going to change colours. Let's go to purple. So we have if p is moving, so we're going to use, still going to use v equals this 3t to the half I minus 2t j, right?
Yeah.
Now which way are we going to do this? Find the value of t at intervals when p is moving to I minus j.
It should be like upside down.
What's that, Ollie? You broke up.
Would it be like an upside down L?
What do you mean an upside down L?
So I would go to the right, and then L and J.
Oh, the direction. Yeah. This is what you mean. It's going I and J. Yeah. So I was wondering what I thought you was talking about writing a letter. So that's I, and that's minus J. That's where it's going to be. So we could, but it does say find the value of t, and if we go back to this last question, it finds the value of v, and we need to find t. I show you, just saying that should work. So what it is 3t to the half I minus 2t, that's equals sum k I plus j, I minus j. That should still work that way. So so what you get is 3t to the half, right, equals I, so which is just k, right, ki, that's ki minus kj. So we're matching up to I equals k. So you can see why this bit, it says this in the mark scheme. So minus 2t, right, minus 2t has to equal minus k. Can we see that? So 2t equals k. Does that make sense, people?
Yeah.
Yeah, so, because if I just show you that, and then I was getting confused why the mark scheme just showed you that. Do we know what to do for C? It says when t equals 1, r equals minus j, find an expression for r in terms of t. So what do we need to do?
Differentiate.
Is it, what do we need to do?
Oh wait, no, we need to integrate.
There you go, that's very important, we can't mess that up. Brilliant work. So that's v in respect to dt. Now we've got v, right? So r equals this, so this is your technically your ideal working out. J in respect to dt, writing that correctly is going to be worth a mark. So we integrate that, show your steps, because this should be worth, or the section of this will be worth a mark. So add the power by 1 divided by 3 over 2, that's I minus, well, that would be 2t squared over 2j, and then what do we need to add? The plus c. Now we're going to simplify that to r equals 2t 3 over 2 I minus t squared j plus c. Now we can sub in what we have up here, which you're good at. So when t equals 1, r equals minus j. So what we're going to get is minus j equals essentially 2 times 1 to the power 3 over 2i minus 1 squared j plus c. And if we rearrange that, we're going to get, that's a minus j plus a j over, this is going to be 2i, this is minus j equals c. So you could see c is just going to equal 2. It's going to be minus 2i, so be careful. And then we just write that down, right? J minus 2i, and that's in meters. Now we do write it neatly because we want to write the i's together, right? Like how it's done in the previous question. So we write all the i's together, and it says in terms of t, so we just factorize that. 3 over 2 minus 2i and minus t squared j. And that is another 3 marks. That's 8 marks that you can all do, and then you would have aced it. Alright, that's brilliant, Will, well done. But then you would have got 8 marks right there, right? And B